let's just sketch the functions we know. We know x to the first is a linear function. X squared, quadratic. X cubed, cubic, and that's what it looks like. X to the fourth, quartic, and that's what it looks like. X to the fifth, this is where I want you guys to start trying to discover the pattern. And once you find it, unmute or put it in the chat box. What do you notice? X to the sixth, we haven't seen this one yet. X to the seventh. X to the eighth. X to the ninth. X to the 10th. You guys want to make me do x to the 10th? I know Kaylee said something, but come on, chime in. What do we see? X to
For
the
odd and even ones are different?
Yes. Yes, I 100%. Do you guys see that? Do you see that the odd and the even are different? And it also, in the chat box, I also see the number of lines or squiggles is equal to the number of the exponent. The number of lines or squiggles is equal to the number of the exponent. That's totally true. If we call them, we call them turning points usually, like where the function turns. And it says like turning points are always one less than the exponent, but that means the number of lines that we see is the same as the number of exponents. But let's go back to that even and odd look different. Let's just focus on the evens. Here's an even, here's an even, here's an even, here's an even, here's an even. Look at just those evens. What do you guys notice? What makes these different than the odds? What do you notice?
The arrows for the odds are going like down then up, and then the arrows for the evens are both going up for the endpoints.
Yeah, do you guys see that? So I just highlighted all the even functions. The arrows are all going up, meaning on both ends of the function, it goes up. If I were to draw this graph, it goes all positive. If I look at my odd functions, one goes down and one goes up. Odd function, one goes down, one goes up. Odd function, one goes down, one goes up. Another odd function, guess what? One goes down, one goes up. Odd function, one goes down, one goes up. If I actually did draw x to the 11th, I know I stopped there, but if I drew x to the 11th, one would go down and one would go up. So this is this predictable thing we call end behavior. And I'm going to shrink this and put it down here because we are going to write some notes on end behavior. And we are going to write them as even degrees and odd degrees. So let's start with even degrees. And we're going to draw just one even degreed function and talk about that one function. So I'm going to draw x squared because I think we all are pretty familiar with x squared. Y equals x squared. So let's talk about this. We said that both ends go up. Well, we have a way of writing that mathematically. This says as x goes towards negative infinity. So as we look on the negative end, going towards negative infinity, where does our graph go? It goes up. But do we have some sort of a mathematical word or mathematical number that means it goes up forever and ever and ever?
Infinity?
Yeah, infinity. So as x goes to negative infinity, f of x, our actual function, goes to positive infinity. It goes up. Okay, let's explore the other side. But what about the other side? As x goes off to positive infinity, meaning as we go in the positive direction forever and ever and ever, as x goes to positive infinity, our function also goes up. So our function goes up, which our mathematical word meaning it goes up forever and ever and ever means it goes off to infinity. So why are we going over this? Why are we defining this? This is true for all even functions. This is true for every single even function. I'm going to write even degree functions because that's what we're looking at. We're looking at the degree. So what exactly is true? It's this. It's this entire statement of as f of x goes to negative infinity, it goes up to infinity. As f of x goes to positive infinity, it goes up to infinity. All even functions will behave the same way. And we see that in those little sketches I did across the bottom. So let's define the same thing for odds. Let's define the same exact thing for odds. And I'm going to start by just drawing an x cubed function, a really basic x cubed function. So x cubed increases and then flattens out right along the origin and then keeps increasing. Okay, let's explore either end of it. Let's go towards the negative end first. As we go out to negative infinity, or as we look to the negative x end of our graph, where is our function going? Down. And guys, we have a mathematical number, a mathematical word to express it goes down forever. As x goes to negative infinity, f of x, our cubic function, goes down also to negative infinity. Do you see how those match? Negative infinity matches negative infinity. Let's go to the other side. As we approach positive infinity, meaning as we look to the far positive end, I'm looking to the far positive x's. As x goes towards positive infinity, you guys tell me, where does our function go? It goes up. How do we note that? We note that as positive infinity. And once again, I want you guys to notice they match. This is true for all odd degree functions. It's true for all of them, whether it's x to the third, x to the fifth, x to the seventh, even that x to the 67th I drew on the last page, that x to the 67th, it will still go down on the negative side and go up on the positive side. It will still do it. I always know odd functions, one side is going down, one side is going up. So the way I think of this really briefly is to say, well, even degrees, both sides are going to go up, or both sides are going to go in the same direction. Odd degrees, one side's going down, one side's going up. They're going in different directions. Now, we have some practice problems going forward, and we will see a certain case where instead of both evens going up, both evens go down. And we will see a certain case where instead of odds starting down and going up, it flips, starting up and going down. But the main idea is that evens will always go in the same direction, always in the same direction, and odds will always go in opposite directions. So your task today that we're going to do together for the most part is just being able to look at a function either in a graph or in an equation and write the end behavior. Let's try this. So go ahead and pull up task 3.3, go to number 1, go to number 2. Start by just trying to write anything you know about that function. Any